Welcome from the Visual Data Extractors. I'm going to be talking about visual to natural language converter. This is the members of our wonderful team, all five of us. So the summary of the challenge is that the team were tasked with developing a system that can convert images of tables and graphs to machine readable text. So the difficulties we're going to be facing was that getting the information out of the graphs to be able to then convert it into the data, and also then pull out just the relevant information from the outline of the graph to then you start to then interpret the information and provide relevant descriptions.
The challenges we face are lack of standardization, missing data labels, incomplete data representation, color recognition or differentiation.
We explored various resources such as cloud providers' websites, research papers, and relevant libraries to enhance our understanding and improve the accuracy of our methods on extracting data from graphs by employing machine learning techniques. We performed classifications using a pre-trained model, which was AlexNet in this case, to identify various chart types including scatter plots, bar plots, and pie charts. We have also managed to achieve an accuracy of 93.85% on our model, and we have shown our results using 3 test cases, which are available on the PPT and on our IPy NB notebook. The model is scalable, which means that it can also be used for more than 6 categories of graphs, and it is ready for new data. This slide shows 2 test cases that we worked on. The first test case shows the line charts, and the second test case shows the flow chart. So the model could correctly predict both of them. In this case, a flow chart too. A flow chart is a little more difficult to identify since it also contains various shapes and sizes. So our model could predict a flow chart as well and can be categorized and can be used to scale to various different categories as well.
So another tool we used to complete this challenge was a natural language processing bot, which was a Python tool that took the GLEADS data that was provided to create a graph and used the ChatGPT API call to describe the data presented in that graph. So as we can see from the live demo on the left, we've installed ChatGPT API call to the notebook, and we've run the data from a CSV into the notebook to create the graph below. What we've also done in the script is triggered a ChatGPT prompt to describe the data set. So what it returned was, this dataset contains construction output values in millions of dollars from Q1 2011 to Q4 2022. There are a total of 57 data points, and the values range from a low of 2,600 in Q2 2020 to a high of 5,400 in Q2 2022. Moving on, what we also asked was for ChatGPT to provide some statistics on the data which hadn't been provided in the script. So as you can see here, what is provided is 3 different averages as well as the range and the standard deviation. Building on, we decided that we wouldn't want the ChatGPT prompt to be in the script, so what we did is we used the Python function input to ask the user to write their own prompt. So here the user has written describe the data, and it has returned the following. It says the data set consists of construction output values in millions from Q1 2011 to Q4 2022. So what we wanted to do then is make sure that we can repeat it. So we used another graph that was provided by GLEADS, as you can see below, ran it through the code, and again triggered the ChatGPT prompt. We've asked the user to input, which says describe the data, but also use statistics in the description. So once we fired that off to the API call, what it will do is it will look at the data in the graph, as well as send the request to OpenAI and then return the text. So the text will say, this data set contains values for construction output in the millions for a given quarter from Q1 2011 to Q4 2022. The highest construction output value was recorded in Q4 2021 with 5,100 million, and the lowest was recorded in Q2 2022 with 2,600 million. The average construction output value across the entire data set is 4,040.95 million. There's been an overall upward trend in construction output, with the most significant growth occurring from Q2 2020 to Q3 2021, when the value increased from 2,600 million to 5,100 million. And this is how we've used ChatGPT to describe the data in the graph.
We were asked, if you had more time, how would you approach this challenge differently? We would have used YOLO, which is an object detection algorithm used for computer vision and real-time object detection. YOLO could mark the bounding boxes around the graphs, create labels containing the object classes, and bounding box coordinates. The annotated dataset could then be used to optimize the loss function to learn to detect and localize graphs and tables within the images.
So our second question is, have you considered the security and privacy aspects of handling sensitive or confidential data that may be present in the visuals, and how does your system ensure data protection? So our solution currently only uses publicly available data from the visuals created by GLEADS and other open sources for the classification model and the natural language processing bot. If GLEADS were to use the solution for commercially sensitive data or for individuals, the below risk would need to be considered. When sensitive data is shared with ChatGPT, there is always a risk of unauthorized access or breaches if appropriate security measures are not in place. Organizations must also ensure they have a legitimate reason for using sensitive data with ChatGPT and obtain the necessary consent. And if sensitive data is transferred outside the European Economic Area, GDPR imposes restrictions on such transfers. So those are the risks for our solution.
So our final question is, have we ever considered the potential limitation of our solution? Yes, we have considered the several limitations of in our solution. One is the ChatGPT manipulates the data. If we ask for statistics, it might give random numbers. We can't fully rely on it. Second is if we rely on ChatGPT APIs. So if ChatGPT went down, it is ineffective. And the third is our model only can identify basic 6 graphs. It can't get into the complex graph